So this is for ETE 100, our practical test number 3. And our project was a band reject filter circuit and frequency response curve showing the frequency and cutoff frequencies. So we have a nice little diagram there that we'll let our partner get into. The first thing we did is we did our calculations for the resonant frequency. Given the inductance and capacitance at 100 microhenry and 0.047 microfarads, the frequency is going to equal 1 over 2 pi times the square root of the inductance times capacitance, which is 1 over 2 pi times the square root of 100 times 0.047, which gives us 0.0734 hertz or 73.4 kilohertz. The next calculation we did was for the impedance and voltage across resistance, which is actually several calculations. So we have our given voltage, frequency, inductance, capacitance, and resistance.
Okay, so now I can just amp up the voltage at this point.
And here are all of our solutions.
Because when you get to our resonant frequency.
Now, we'll go over to the actual project.
This is our circuit diagram for the band reject filter. We have a function generator as our power source going to our 473 microfarad capacitor, and in parallel with a 100 microhenry inductor going to 1k ohm resistor to ground. This is similar with frequency and voltage what our pattern will look like. Over here we have power source, or negative and positive, hooked to our function generator. We have our power source going to our 473 microfarad capacitor in parallel with our 100 microhenry inductor through our 1K resistor to ground. Up here on O-scope is what we're seeing when we make our course frequency adjustments.
Yeah, and it looks like we're getting that big change there right around somewhere between 0.06 and 0.07 hertz, which is what we calculated as 0.0734 hertz. Okay. And that's our project.
I'm ready to record.